Hello, everybody. How are you guys doing? Today we are going to have some fun and we are going to play Bitcoin lottery. It's not very likely that you will find a Bitcoin by coincidence anytime in your lifetime, but it's still worth trying just to have some fun. This way of playing a lottery gives me a better feeling than actually going and buying a lottery ticket just simply because I don't spend any money and I'm still playing the lottery while I'm asleep and in my free time. We will create Python scripts to dig the network for some addresses with balances larger than zero. I'll be using Ubuntu 20 for that purpose. As far as I can remember, the library didn't work very well for me with other Ubuntu versions. I'm setting up virtual environment for my project. Let me call it project number 5. The library to use is called Bit, and as of the day of recording, the newest version is 0.8.0. The installation is very easy. All you've got to do is type pip install bit. Bit is Python's fastest library and was designed from the beginning to feel intuitive, be effortless to use, and have readable source code. And let's test if it works. From bit import key, which will generate a random private address. Oops. Let's try again. So what's the difference between legacy address and the SegWit address? Legacy address is the original Bitcoin address, while SegWit is the newer address format with lower fees. And what is WIF? It is the wallet it is the wallet import format. It is a standardized way of displaying private Bitcoin keys. Once you have your private key, which is meant to stay private, you can generate a public key which you can share because with the public key you can actually receive your Bitcoin into your wallet. Let's generate a new private key. It is super easy to get the balance with the get balance method. You can display the balance in Satoshi as well as in dollars. Here I have a private key with a balance in it, and let's display the balance. Here is the balance in Satoshi, and the equivalent balance in dollars is 12. It's just over $12. Let's run the first Python script. Each time you run the first example, you will always get a unique private and a public key, along with the balance, if there is any, of course. we are importing key from the bit library. In the line 6, we are generating a new private key, and in line 7, we are displaying the public address. In line 8, we are displaying the SegWit format of our public key. Then from line 10, we are moving into the private section of the key, and in line 12, we are displaying the wallet import format of our private key. In line 15, we are displaying balance, if any, in Satoshi, and in line 18 and 19, we are showing the balance in a fraction of Bitcoin as well as in the dollar amount. So this is as easy as that. You can generate as many private keys as you wish and always check the balance. Before I show you the second example, let us import the key module. We will generate a new private address and convert it into a string of digits. The string of digits can be also converted into a public address. So let's use that property and create a second example. And again, we are getting a balance for our string, which is 0. In the second example, we are giving our script an integer, in this case, all the numbers between 1 and 9, converting that string of digits into an address, and displaying a balance. Very easy indeed. So you can create a key from integer, you can also change a key back into an integer, which is just a string of numbers. The third example works a little different. Here we are starting with a string, some random letters of your choice, and then generating an ASCII from each letter of the string. Then we're merging together those integers. And from that, we are getting our private addresses. Let's generate our text into this is a BTC lottery and see what we get as a balance. And in the last example, probably the most efficient way of checking for balances in randomly generated addresses is to create an infinite loop where the addresses are generated and the balances are checked. We are importing the time module and we are going to check the time it takes to check each single address. If the balance in Satoshi happens to be larger than 0, we will have our private address shown on the screen along with the balance. And of course, we can open more terminals just to run the same script in multiple windows. And this way we will generate more addresses within the same period of time. Thanks guys for your attention and I hope to see you soon. Bye.